All right, we're back and ready to dig even deeper into India's lunar missions, specifically Chandrayaan-3, which is launching pretty soon,
Mhm.
and then we'll look ahead at Chandrayaan-4. The big thing about Chandrayaan-4 is it's aiming to bring lunar samples back to Earth. That would be a first for India, a pretty big leap for their space program.
Yeah, it's really amazing to watch how the ISRO, that's the Indian Space Research Organization, how they're building on what they've learned. Chandrayaan-1 back in 2008, that was the one that discovered water molecules on the moon, remember? And even though Chandrayaan-2 had that setback when the Vikram lander crashed in 2019, the orbiter from that mission is still sending back some really useful data.
So Chandrayaan-3 is almost here. And it seems like it's really all about getting the landing and the rover operations right this time. What's the plan for this mission?
Well, they've simplified things this time around. No orbiter for Chandrayaan-3, just a lander and a rover. They're laser focused on what they call a soft landing on the surface of the moon, which means using all sorts of high-tech navigation to make sure the lander touches down nice and gently, which, believe me, is not an easy thing to do in that lunar environment.
Okay, so paint a picture for me. The lander gets down to the surface. What happens then?
Well, think of the lander as the delivery system. It's got to get that rover safely down to the surface. Then once it's down, that's when the real exploring can begin.
So the rover is our explorer on the moon, right? What's it going to be doing up there?
Exactly. It's got all these cool instruments to analyze the lunar soil, what they called regolith. It's this loose, broken up layer on the surface of the moon, formed over billions of years by, impacts from meteorites and solar radiation. The rover is going to study what the regolith is made of, identify any minerals that are there. Basically, it'll be giving us a close-up view of what's happening on the surface.
That's pretty awesome. But I remember reading that this mission is also about showing off India's technology. What are they hoping to prove with Chandrayaan-3?
It's all about showing that they can carry out these really complex missions to the moon with precision and skill. Think of it as a technology demonstration.
Yeah.
It's paving the way for even more ambitious missions later on, maybe even sending people to the moon someday.
Now you're talking. Okay, let's switch gears to Chandrayaan-4 for a minute. That mission is trying to bring a piece of the moon back to Earth. That's pretty wild, right?
It's super ambitious. To actually pull it off, they'll need a much more complicated system than what they're using for Chandrayaan-3. We're talking multiple spacecraft, all working together perfectly.
Okay, sounds complicated. Break it down for me. What are the main parts of Chandrayaan-4?
Well, you've still got your lander and your rover, but this time there's also an orbiter, an ascent vehicle, and a return module. It's like a whole space orchestra.
A lot of moving parts there. What does the orbiter do in all of this?
That's kind of the mission control center in space. It handles all the communication, relaying data back and forth between Earth and the lander and rover down on the moon. It'll also be making detailed maps of the lunar surface. That's important for picking the best landing site and for helping the rover to get around.
So the rover will be the one collecting the moon samples, right? How does it decide what to bring back to Earth?
Imagine it's like a robotic field geologist. It has all these instruments for figuring out what the lunar surface is made of, and it can spot scientifically interesting samples. It's programmed to pick samples that show the variety of the geology at the landing site, and the samples that are most likely to tell us something new about how the moon formed and its history.
All right, so then how do those samples actually get back to Earth? We've got an orbiter, a lander, and a rover, but there's more, right?
That's where the ascent vehicle comes in. Once the rover has collected all its precious samples, it takes them over to the ascent vehicle, which is basically a mini rocket just sitting there on the moon waiting.
Wait, so we're launching something off of the moon. That's crazy.
It's a delicate maneuver, but to bring samples back, it's essential. The ascent vehicle blasts off from the moon, carrying those lunar samples, and then it has to meet up and dock with the orbiter, which is patiently orbiting the moon.
It sounds like a perfectly choreographed dance in space.
It really does. And then once the ascent vehicle is docked and the samples are safely transferred to the orbiter, it's time for the final act, the return to Earth. That's where the return module comes in. It detaches from the orbiter, carrying those precious moon samples, and it makes the long trip back through Earth's atmosphere.
But wouldn't the heat of re-entry destroy those samples?
That's the big challenge. The return module has a special heat shield to protect the samples from the incredibly high temperatures it encounters as it comes back into the atmosphere. It's like carrying a really delicate package through a raging fire.
So Chandrayaan-3 is all about mastering the landing and rover operations. And then Chandrayaan-4 takes it to a whole other level by trying to bring pieces of the moon back to Earth. Both missions are going to the moon, but they're very different.
Yeah, it's fascinating how each mission builds on the last one. Chandrayaan-3 is laying the groundwork, proving what India can do. And then Chandrayaan-4 pushes the limits even further, bringing back samples that could change our understanding of the moon and the entire solar system.
Okay, I'm hooked. Let's dive into the main differences between these missions, see how complex they are, and what kind of scientific impact we can expect from each one. I want to understand what makes them unique and why they're so important.
Let's start with the core goals of each mission. For Chandrayaan-3, the main goal is to show that they've mastered landing on the moon and operating a rover there. It's all about proving that India can do these tricky maneuvers with precision and accuracy.
But Chandrayaan-4 is about bringing back actual pieces of the moon, right? That's got to be way more difficult.
Absolutely. Chandrayaan-4 is designed to collect lunar samples and bring them back to Earth for scientists to study. That requires a whole new level of technology.
Okay, I get the objectives. But what about the complexity of these missions? I'm guessing Chandrayaan-4 is way more complex.
You're exactly right. Chandrayaan-4 needs a much more complicated spacecraft and mission plan than Chandrayaan-3, adding the ascent vehicle and the return module, and all those delicate maneuvers for rendezvous and docking. That adds a whole new level of complexity that you just don't have with a landing and rover mission.
Can you give me a specific example of what makes Chandrayaan-4 so much more challenging?
Well, think about the ascent vehicle launching from the moon's surface. It has to reach escape velocity to break free from the moon's gravity, and then it has to navigate perfectly to meet up with the orbiter. It's like threading a needle in space.
Wow, that does sound incredibly difficult. So how do these differences in complexity affect the science that we can get from each mission?
Well, both missions are going to give us valuable information about the moon. Chandrayaan-3, with its lander and rover, it'll be analyzing the lunar surface right there on the spot, sending back real-time data about the composition of the surface, the minerals that are present. It might even detect water ice in those permanently shadowed craters.
But Chandrayaan-4, because it's bringing back samples, has the potential to totally change how we understand the moon, right?
Exactly. Having those physical samples back in labs on Earth, that lets scientists do so many more types of analysis, using sophisticated equipment and techniques that you just can't put on a rover.
So we might find things in those samples that we wouldn't even know to look for if we were just studying the surface.
Precisely. Imagine analyzing the isotopes in lunar rocks, studying their magnetic properties, dating them with incredible precision, maybe even finding traces of organic molecules, which could give us clues about the early solar system, maybe even about the possibility of life existing somewhere else. It opens up a whole new world of scientific possibilities.
Amazing. I could already picture scientists huddled around those samples, making groundbreaking discoveries. I know that both missions are considering the lunar South Pole as a landing site. What makes that area so interesting?
The south pole of the moon has been fascinating scientists for decades, mostly because of the potential for water ice in those craters that are always in shadow.
Okay, we've talked about lunar water ice before,
Mhm.
but I want to make sure I understand why it's such a big deal. What makes it so valuable?
Water ice on the moon opens up so many possibilities for future exploration of the moon and even for setting up a permanent human presence there. Think about it. We could use it for drinking water. We could use it to generate oxygen for breathing. We could even use it to make rocket fuel.
So we could have a lunar base that can sustain itself, using resources that are already on the moon. That's mind-blowing.
Yeah.
But it's not just about practical applications, right? What about the scientific value of lunar water ice?
Scientifically, it's like a time capsule, preserving information about the early solar system. It could tell us how water got to Earth, how many impacts there were in the inner solar system, maybe even about the possibility of ancient life somewhere else.
So the south pole of the moon is like a treasure chest of scientific potential, and both Chandrayaan-3 and Chandrayaan-4 might be going there.
It's definitely an exciting time for lunar exploration. But there's another aspect of these missions that's really important to highlight, especially for such an ambitious project like Chandrayaan-4.
You're talking about international collaboration, right? I've heard that scientists and space agencies from all over the world are interested in these missions.
Exactly. Chandrayaan-4, with its goal of bringing back lunar samples, it's creating these incredible opportunities for scientific collaboration on a global scale. Scientists from all over the world will be able to study those samples, share their data, and work together to unravel the mysteries of the moon.
So it's not just about India's space program, it's about fostering a global spirit of exploration and scientific cooperation.
Exactly. These missions are a real testament to the power of international collaboration in tackling some of the most challenging and rewarding endeavors in space exploration. And what's really fascinating is that these missions, Chandrayaan 3 and Chandrayaan 4, are really part of a much bigger story, a story that goes back centuries.
You're talking about humanity's fascination with the moon.
I mean,
Yeah, it's been this source of wonder and inspiration for as long as we've been looking up at the night sky.
exactly. Think about it. Early astronomers carefully mapping its surface, poets and storytellers creating all these tales about its silvery glow, scientists and engineers dreaming of actually reaching its surface.
And then, of course, there's the Apollo program.
Huh.
When we finally set foot on another world, it was a huge moment for humanity.
Absolutely. The Apollo missions, they captivated a whole generation, and they led to so many advancements in science and technology, advancements that we're still benefiting from today. But even before Apollo, there were all those robotic missions, exploring the lunar environment, sending back so much valuable data. They paved the way.
So Chandrayaan 3 and Chandrayaan 4 are building on this incredible legacy of lunar exploration. It's amazing to think about how much we've already learned about the moon. And yet there's still so much more to discover.
That's what's so cool about scientific exploration, right? The more we learn, the more we realize how much we don't know. We've discovered that the moon probably formed from this giant impact early in the solar system's history, that it has a surprisingly diverse geology, and that it even has water ice hidden in those permanently shadowed craters.
And with missions like Chandrayaan 3 and Chandrayaan 4, we're going to uncover even more secrets, fill in those gaps in our knowledge. We might even rewrite what we thought we knew about the moon's role in the whole grand cosmic story.
Exactly. These missions represent not just India's ambition in space, but this shared human desire to explore, to discover, to learn. Each mission gets us closer to understanding how the moon formed, how it evolved, and how it's connected to our own planet.
Okay, but let's bring it back down to Earth for a second.
Yeah.
What does all this lunar exploration mean for us here and now? Why should we care about what's happening on the moon?
That's a great question. And there are actually several reasons why exploring the moon is so important. First of all, it's about advancing our fundamental scientific knowledge. The moon is like this time capsule, preserving clues about the early solar system. Clues that have been erased here on Earth because of all the geological activity and weathering.
So by studying the moon, we're basically looking back in time, trying to understand how our own planet formed and evolved.
Exactly. The moon can help us answer these big questions about how planets form, about the history of impacts in the inner solar system, and about the conditions that led to the emergence of life on Earth. But it's not just about looking back in time, it's also about looking ahead to humanity's future in space.
You're talking about the potential for lunar resources. Things like water ice, helium-3, rare earth elements.
Exactly. Those resources could be crucial for supporting future human exploration, for setting up a sustainable presence on the moon, and even for developing new technologies and industries here on Earth.
So exploring the moon isn't just about scientific curiosity. It's about laying the groundwork for a future where humanity has a presence beyond Earth.
Absolutely. It's about expanding our horizons, becoming a multiplanetary species, and making sure that humanity can survive in the long term. And with missions like Chandrayaan 3 and Chandrayaan 4, India is showing that it's a growing force in space technology and exploration, demonstrating its commitment to advancing scientific knowledge.
It's really exciting to see India emerge as a major player in space exploration. It's a reminder that the pursuit of knowledge and the spirit of discovery go beyond national borders and cultural differences.
Space exploration is a truly global endeavor, and missions like Chandrayaan 3 and Chandrayaan 4, they bring people together from all over the world, united by a shared passion for exploring the cosmos and unlocking its secrets.
It's not just about the scientific discoveries and the technological advancements. It's about the inspiration, the sense of wonder, the expansion of human consciousness that comes with exploring the universe beyond our planet.
These missions remind us that we're not just inhabitants of Earth, but citizens of the cosmos, with a responsibility to explore, to learn, and to share our discoveries with the world.
And with Chandrayaan 3 and Chandrayaan 4, India is contributing to this grand human endeavor, pushing the boundaries of what's possible and inspiring the next generation of explorers. So what other exciting developments are happening in lunar exploration right now?
Well, we're seeing a resurgence of interest in the moon all over the world. NASA's Artemis program, for example. It's this ambitious international effort to send humans back to the moon and to establish a sustainable presence there.
Yeah, I've been hearing a lot about Artemis. What makes it so significant for lunar exploration?
Artemis is a big step forward, not just in terms of the technology involved, but also in terms of international collaboration. It involves partners from all over the world, all contributing to this ambitious goal. It's not just about planting a flag on the moon this time, it's about building a lasting infrastructure for scientific research, for using lunar resources, and maybe even for setting up future settlements.
It sounds like we're on the edge of a whole new era of lunar exploration. An era where we're going back to the moon not just to visit, but to stay. And it's not just government agencies leading the way, is it?
You're right. We're also seeing the rise of this whole new space economy, with private companies playing a key role in this new era of lunar exploration.
It's amazing to think about all the possibilities. What are these private companies focusing on?
They're developing all sorts of innovative technologies for lunar transportation, habitation, resource extraction. We're talking about companies building lunar landers, rovers, habitats, even technologies for mining lunar resources.
It's a truly exciting time. With all these technological advancements, scientific discoveries, and entrepreneurial spirit, all coming together to drive us towards a future where humanity has a permanent foothold on the moon. And missions like Chandrayaan-3 and Chandrayaan-4 are paving the way, showing what's possible and inspiring the next generation of scientists, engineers, and explorers.
They're showing us that the moon isn't just some distant object in the sky, but a world full of potential, a world that might hold the key to unlocking some of the biggest mysteries of the universe. And speaking of unlocking mysteries, we should talk about the people behind these missions.
You mean the scientists, the engineers, the technicians, all the countless people who make these missions possible?
Exactly. They're the unsung heroes of space exploration. People who pour their hearts and minds into these endeavors, pushing the boundaries of what's possible.
It's important to remember that space exploration isn't just about robots and spacecraft. It's about human ambition, ingenuity, and collaboration on a global scale. What are some of the unique challenges faced by the teams working on Chandrayaan-3 and Chandrayaan-4?
One of the biggest challenges is just the sheer complexity of these missions. You're talking about coordinating multiple spacecraft, developing cutting-edge technologies, operating in this harsh environment of space. And then there's the challenge of working with a limited budget. ISRO has this amazing track record of achieving ambitious goals with relatively limited resources.
It really speaks to their ingenuity and resourcefulness. What about the human element? What are the personal stories, the triumphs, the challenges that the people working on these missions experience?
Behind every successful mission, there are countless stories of dedication, perseverance, and teamwork. You have engineers working around the clock to solve complex technical problems, scientists analyzing data late into the night, technicians making sure that every single component is perfectly assembled and tested.
It's inspiring to think about the passion and dedication that drive these individuals. They're not just building spacecraft. They're building dreams. They're pushing the limits of human knowledge.
They're reminding us that anything is possible if we dare to dream big, and if we work together to achieve our goals. And their work isn't just about advancing science and technology, it's about inspiring the next generation.
Speaking of inspiration, what kind of impact do these missions have on young people in India and around the world?
These missions are a source of immense pride for India, and they're a powerful inspiration for young people to pursue careers in STEM fields, science, technology, engineering, and mathematics. When they see their country achieving these ambitious goals in space, it sparks their imagination and encourages them to reach for the stars.
It's about showing them that anything is possible if they set their minds to it. And it's not just about inspiring future scientists and engineers. It's about fostering a sense of wonder and curiosity in everyone.
Exactly. Space exploration has this unique ability to capture the imagination and to inspire a sense of awe and wonder in people of all ages and backgrounds. It reminds us that we're part of something much bigger than ourselves, that there are still frontiers to be explored and mysteries to be uncovered.
It's a reminder that the human spirit of exploration knows no bounds, and that the quest for knowledge and discovery will continue to drive us forward, ever onwards, to the stars. And while these missions are focused on the moon, they represent something much bigger. They represent our innate desire to explore the unknown.
They're a testament to human ingenuity, our relentless curiosity, our capacity for collaboration. They remind us that the spirit of exploration is alive and well, and that there are still frontiers to be crossed. Speaking of frontiers, let's shift our focus to the specific landing sites being considered for Chandrayaan-3 and Chandrayaan-4.
Okay, let's talk about where these missions are headed on the lunar surface. We've touched on the lunar South Pole, but what other exciting locations are on the short list?
Well, the South Pole is still a top priority, mainly because of the potential for water ice in those permanently shadowed craters, but there are other intriguing areas being considered as well.
Like what? Tell me more.
One possibility is the South Pole Aitken Basin. It's one of the largest and oldest impact basins in the entire solar system. It's a region with incredible geological diversity.
Why is the South Pole Basin so scientifically interesting? What makes it stand out from other places on the moon?
Well, the South Pole Aitken Basin is kind of like a window into the moon's really ancient past. Scientists think it formed from this absolutely massive impact billions of years ago, an impact so powerful that it dug up material from deep inside the moon's mantle. So studying this basin could give us some really valuable clues about what the inside of the moon is made of and about the processes that shaped it way back when it was first forming.
Wow, it's like a giant natural excavation site, revealing secrets that have been hidden for like billions of years. What kind of samples could we potentially find there?
Well, we might find rocks that are totally different from the ones we find in the lunar highlands, rocks that come from the moon's original mantle. Analyzing these samples could completely change our understanding of lunar geology, and it could help us understand the early solar system's bombardment history.
I can already picture those samples being brought back to Earth, being analyzed in labs all over the world, sparking all sorts of new discoveries and scientific debates.
It's definitely an exciting prospect. And the South Pole Basin isn't the only interesting place on the shortlist. The lunar highlands, those ancient, heavily cratered areas that cover most of the moon's surface, they're also being considered as potential landing sites.
What makes the highlands so special? Aren't they just these vast, empty landscapes?
They might look desolate at first glance, but the highlands are actually packed with scientific information. They're thought to be made up of the moon's very first crust, the material that solidified from a global magma ocean early in the moon's history. So studying the highlands could tell us about the processes that shaped the moon's early evolution and about how its interior differentiated.
So it's about putting together the pieces of the puzzle of the moon's formation, understanding how it went from this molten ball of rock to the celestial body we see today.
Exactly. And each potential landing site offers a unique piece of that puzzle. The South Pole, with its potential for water ice. The South Pole Aitken Basin, with its glimpse into the lunar mantle. And the highlands, with their ancient crustal rocks. They all contribute to a richer, more complete understanding of our closest celestial neighbor.
It's amazing to think that these missions could be collecting samples that are billions of years old. Samples that hold the key to unlocking some of the biggest mysteries of our solar system.
Yeah.
But with so many fascinating locations to choose from, how do scientists actually decide on the perfect landing site?
It's a really complex process. They have to balance the scientific goals, the engineering challenges, and the safety of the mission. Scientists want to go to places that are likely to give them the most valuable data and samples, while engineers focus on things like the terrain, the lighting conditions, and whether they can maintain communication with the spacecraft. And of course, the safety of the mission is the top priority.
So it's a collaborative effort, with scientists and engineers working together to find the best spot, a place that's scientifically valuable and also feasible for the mission.
Exactly. And it's not just about choosing the landing site itself. They also have to plan the rover's traverse, the path it's going to take to explore the area and collect those precious samples. Every step is carefully planned to get the most scientific value out of the mission.
It's like planning a huge expedition, but instead of mapping out a route through a jungle or across a desert, we're charting a course across the lunar landscape.
That's a great way to put it. And just like any great expedition, the success of Chandrayaan-3 and Chandrayaan-4 depends on meticulous planning, cutting-edge technology, and the unwavering dedication of the teams behind them.
It's really inspiring to see all of this come together. Human ingenuity, scientific curiosity, and incredible technology. These missions represent the best of what we can achieve when we set our minds to exploring the unknown.
They remind us that we're capable of extraordinary things when we work together towards a common goal. And as we look ahead to the future of lunar exploration, it's clear that these missions are just the beginning.
What other exciting developments can we expect in the years to come? What does the future hold for our exploration of the moon?
Well, we're entering a whole new era of lunar exploration, an era marked by international collaboration, commercial involvement, and really ambitious long-term goals. The Artemis program, with its plans for a sustainable lunar presence, is a perfect example of this.
It sounds like we're on the verge of a lunar renaissance, a resurgence of interest and activity that will completely change our relationship with our closest celestial neighbor.
And India, with its ambitious Chandrayaan missions, is playing a key role in this exciting new chapter. These missions aren't just about scientific discoveries, they're about pushing the boundaries of what we know, inspiring future generations, and paving the way for a future where humanity becomes a multiplanetary species.
It's a journey that fills me with a sense of wonder and excitement. As we wrap up our deep dive into Chandrayaan 3 and Chandrayaan 4, I'm left with a profound appreciation for the ingenuity, the dedication, and the collaborative spirit that drive these incredible endeavors.
I hope this deep dive has given you that same sense of awe and inspiration. Keep looking up at that night sky, keep asking questions, keep exploring. And who knows, maybe one day you'll be part of a team sending a spacecraft to the moon, or even beyond.
It's a fantastic thought. And on that note, we'll wrap up this deep dive. Thanks for joining us on this journey to the moon. We'll be back soon with another deep dive into a fascinating topic, so stay tuned.